Respected Chairperson. This is a 72-year-old female with class 2 dyspnea for the last 9 months. Patient came with an echo function of 26% EF with a moderate MR, and angiogram shows a calcified triple vessel disease where there is an osteal disease of LAD as well as osteal circumflex disease with a Ramus disease. So this was an angiogram showing a tight osteal disease. We tried to put a wire, this called a Philadelphia wire, even the cannulation of the catheter, a 7 French EBU catheter, we can actually see that the wire is going down. And there is a real difficulty in taking the wire into the circumflex. So you can see that the wire is struggling there, but finally, somehow, we managed to take the wire inside. So this was actually the wire is going down. After the wire going down, the most important challenge was how to cannulate the LAD. Initial angiogram taken outside, which was showing some flow, but we tried with a Philadelphia with a fine cross, the wire is not going inside. Then taken a cruise side, a double lumen catheter. Again, the wire is not going inside. So this is the situation here. So all antegrade options failed. A single lumen catheter, double lumen catheter, and an IVUS guided puncture is having no value here because ostium is very clear. Retrograde approach is the next one. We tried to take a Philadelphia wire with two septal collaterals. You can see that these are the two septal collaterals, a single catheter. So we tried to take the wire inside. The wire gone inside, and the wire reached in the proximal part of the LAD, a single French catheter. But this is a Philadelphia wire. Switch the wire into the cyan black. Once the wire is there, the next is actually the wire to be crossed into the LMCA. So you can see that wire is actually struggling. We have to take the microcatheter up. So the microcatheter gone inside, it kept inside, then now the wire is in the proximal part. There is a very acute angulation of the circumflex and the wire is, now you can see the wire has gone inside. It's a single French, not ping pong technique. The wire is gone inside. Now we have to change into the RG3 wire. This is an RG3 wire. That is, once the RG3 wire is exchanged, you have to do a balloon dilatation with a 2x12 microcatheter balloon. So single catheter, RG3 wire is on, 2x12 balloon dilated. After that, there are two ways. Initially, we have taken a fine cross. So we decided to take the same fine cross in the same RG3 wire. So the RG3 wire has two fine cross. One is retrograde, one is antegrade. So taken the RG3 wire. So you can see two microcatheter now, two pin tops. Once the microcatheter is there, you can see a small dissection because actually created by the RG3, bare RG3 wire. Keeping that wire, now you have to cross the wire down. So now we decided to take the wire down, the wire going down. So the wire is actually taken down. Now single catheter, single RG3 wire is there. So now, because of the severe calcium, we have taken a 1.5 rotor burr, 180,000 RPM, 4 runs, 48 seconds. So after the burring, we got a flow like this. Now we decided to do an IVUS to the circumflex to see that whether we have to do a rotor burr into the circumflex also. Once the burr is done, the distal circumflex is tight lesion with osteal circumflex. If you look at the lesion at 2.82, and there is a lot of calcium, 2.76 is the proximal circumflex or osteoproximal circumflex with a 4 millimeter vessel. So we did an IVUS again to the LAD to understand how is the distal LAD is actually having a lot of calcium. And once this calcium is there, we saw the diameter. We can see the distal LAD diameter is actually 3.4 millimeter. So the proximal is. So we decided to take an IVL catheter. Is IVL 3x12 circumflex. We did 30 pulses or 30 pulses is given to the circumflex, and we have dilated with the IVL into the proximal part, taken the IVL balloon into the LAD. We have given 50 pulses into the LAD. So the total 80 pulses are finished. After that, we did an IVUS again to understand what is the size of how the IVL behaved. IVL shows a lot of dissection and a lot of calcium cracks and created an excellent lumen area in the LAD. So now the next point is actually we have to take we prepared the vessel very well. So now it is actually to take the stent. So you can look at the, we have decided to take only 2 stents. One is a 48 millimeter stent of 3 into 48 directly into the LAD. So keeping the catheter there, taking a 3 into 48 stent, you can see the stent is going down. Stent gone down. Once the stent is gone down, you have to do a crushing of the stent by 3.5 into 12 millimeter balloon. 3.5 into 12 millimeter balloon, dilatation done. Not moving. Okay. So now to take a stent into the LAD was, a circumflex was very tough. So we have taken a guide plus, it's actually a guide plus, actually the mother and child catheter taken inside with the help of a balloon down. With that one, you can see the second frame. I have taken a 4 into 48 stent. A 4 into 48 stent is taken down through the guide plus. So 3 into 48 into the LAD, 4 into 48 into the circumflex. After that, this was the result we created. We cannot stop here. We have to do a port balloon with a 4 into 8 millimeter. After the port balloon, we have to recross. Now I'm trying to recross the wire into the LAD because LAD is taken as a side branch because the vessel diameter was less in the LAD and circumflex was 4 millimeter. You can see the wire is coming down. I am recrossing the wire into the LAD. Non-distal cross was the after one. Actually, I wanted to have a not the distal most and one actually crux. Before that, I have to cross. We crossed. After recrossing, we have to take a 2 into 12 millimeter balloon, then 3.5 into 12 into the LAD, 4 into 12 millimeter into the circumflex, and finally we take a 4.5 into 8 millimeter balloon into the LMCA. So this was the, then we have to do an IVUS into the circumflex to see whether the dilatation was perfect or not. We got an area like this. We got 7.75, 8.86, 6.5, and 5.69, which was only 2 earlier with a 14 into the LMCA. This was the final result. Thank you very much.